So we will start seminar, so 3, I think, seminar 3. Now, so we will discuss first order linear differential equations, methods of solving first order linear differential equations, right? First order linear differential equations with non-constant coefficients, arbitrary coefficients, first order. Differential equations. These are equations of the form y prime plus e of x times y equals f of x. So let it be f of x. Or maybe, right, f of x. The equations of this form, where a and f are continuous functions, if this, they may be defined on an interval, maybe not on the entire real line, but maybe on some interval. Okay. And pay attention to the fact that y prime and y both have exponent 1. Right? So, and this is why it is called a linear differential equation. It is linear in y prime and y. They both have exponent 1. Okay, but a of x and f of x may be arbitrary, and we will consider 2 methods. Today we will study 2 methods of solving this equation. So the first method will be, so it will be discussed here. The method of an integrating integrating factor. It is called the method of integrating factor. And the next method will be, the second method will be the variation of the constant. So variation of a constant. Okay. So for the first method, if we consider an integrating factor u of x, let it be e raised to the integral of a of x dx. Let's introduce this function, define the function this way. So we know the function, so the coefficient a of x, we may integrate, find an integral and raise e to this power. Then I claim that if we multiply the left-hand side of this equation by u of x, so we will get the derivative of the product u and y. Let's do this. So let's multiply the left-hand side of this equation by this integrating factor. We will obtain the following: u prime times u of x plus a of x times u of x times y, and it is the same as u prime times e to the power the integral of a of x dx plus a of x times e raised to the power the integral of a of x dx, so times y. I claim that this is equal to the derivative of y times u of x, which is the same as the derivative of y times e raised to the power the integral of a of x dx prime. Let's check this. So I claim that this is the derivative of this function. Kathy, do you know this method? Right?
I learned it.
Okay, you learned it. I see. Okay, so let's differentiate this. So we form this function. So we compute this. It can be computed easily, right? Then multiply y by this factor, and let's find the derivative of it. So this is the derivative of the product. First, we differentiate the first factor. It is y prime times this coefficient u plus, and next let's differentiate. So y is left unchanged, and we differentiate this factor. How to differentiate this? So it is the composite function. So if we differentiate e, we get the same function, and we should multiply by the derivative of the exponent. It is a of x. So we can see that this is the derivative of y times this integrating factor. Okay, this leads this leads to the method of solving this equation, right? So if we multiply both parts by our integrating factor u of x, so I will move here. So we will get the following: u of x multiplied by u prime plus a y equals u of x multiplied by f of x. Then we saw that in the left-hand part we have u times y, or maybe y times u prime, right? It was shown. It is equal to u times f. Y is an unknown function, but u and f are known function. They are, so f is a given function, and u was obtained on this step, on the first step. So this is step number 1, and this is step number 2. So we know right hand side, and we can find, so we know that the derivative of this function is equal to u times f. Then to obtain y times u, we should just integrate, right? Okay, and so I will add c to show that it involves a constant, right? And then to obtain y, we should just divide by the integrating factor. So from this we have y equals the integral of u times f dx plus c over u. So this completes the second part, the second step. Okay, so now I will show you how to solve the first order differential equation using this method. If you don't mind, I will remove this explanation, this part, and I will rewrite the second step here. So you will have the scheme. So this will be the algorithm of solving, and I will use this algorithm. So this way, this part, or maybe just a moment. Maybe I will use this part. The variation of the constant will be described later, and now I will rewrite the scheme here, and I will show how it works. So the algorithm, the first algorithm, the algorithm of the method of integrating factor will be the following. So the first step number 1 will be to find u of x as e raised to the integral a of x dx. And step number 2 is to find y as, so it will be the integral of u times f of x dx plus c divided by u of x. So the method of integrating factor involves 2 steps, right? The first step and the second step. And now let's try to solve an equation, a linear differential equation using this method. So task number 1, let it be y prime minus y minus x e to x equals 0. So first of all, we must rewrite this differential equation in the standard form. This is the standard form. So our equation it isn't in the standard form because we have this function in the left-hand side. So we should move it to the right. And we should rewrite this equation in the form y prime minus y equals x e to x. This is a standard form now. And step number 1, we will find u. To find u, we should first integrate. Integrate what? A is equal to
A of x
negative 1 dx. It will be minus x. Okay, we will not add c, so c is added on the last step, right? So we need just one antiderivative, not all the antiderivatives, right? And what is u? U will be e raised to this power minus x. It is u. This is an integrating factor, and we have found an integrating factor. I may wait. Shall I wait? Right. Step number 1. Okay, and in step number 2, I prefer to solve directly, not use this formula. So I don't want to memorize this, but I have memorized, and I recommend you to memorize the algorithm. It's better. So next, we must multiply both parts of this equation by e to negative x, right? And we will get the following: y prime times e to negative x minus y to e to negative x equals just x. And we should notice that this is the derivative of what? Of y times e to negative x, right? It can be seen, so, right, by direct, so we can check this directly by differentiation, right? Equals x. Next, we must find this function by integrating x, and after this we will divide by the integrating factor, right? So from this we have y times e to negative x equals the integral of x dx. So it is x squared half plus c. And then to find y, we should multiply both parts by e to x. Y is equal to x squared half plus c times e to x. Right, I hope it's clear. Okay. Now maybe I will introduce the second method, the next method, and after this we will try to solve the problems using the first method or the second or both. Of course, the answer should be the same, so it should not depend on the method, of course. So the second method, the method of variation of a constant. Variation of a constant. So it also includes two steps. Step number one is to solve a separable differential equation. So it is called homogeneous. So it is not in the same sense as before. So if f of x equals 0, then these equations are also called homogeneous. Homogeneous in the sense like in so in the same sense as in linear algebra. So homogeneous linear system with a 0 constant terms, right? And this equation is also called a homogeneous linear equation. Homogeneous linear equation if f of x equals 0. So step number one is to solve this homogeneous linear equation. It is separable differential equation. It is separable. So we can separate variables, and so it will be dy over y equals minus a of x dx. Then integrate and from this we have the following. So it will be ln absolute value of y equals, so but it will be the same maybe in some sense, right? Like there, so e raised to the exponent but with minus a of x dx. So not just a moment, not this but y. It's not the logarithm but y, right? So minus the integral of a of x dx, and then y will be equal to c times e raised to this power. Okay, so they are these two methods resemble one another. So the steps, so we perform the same integration in one method and in the other, because so they will lead to the same answer, of course, and so they are similar to one another, right? You can see this. Okay, right, this is the step number one. Step number one. Next, step number two. Okay, on this step we replace the constant. So this is an arbitrary constant, but this is a constant for this homogeneous equation. If we consider our original equation, which has f as a constant, as a function, right, with f, non-homogeneous differential equation, then we should replace this constant with a function. We assume that there exists a function such that y of x equals c of x times e raised to the power a of x dx. So c is replaced by function, and on step number two, we will try to find this function, not now a constant, but a function c of x. So I will wait. Okay. And this is a reason why this method is called the variation of a constant. So this is a constant, but on step number 2, the constant is replaced by a function, so it is varied, right? We can vary this constant, a variation of a constant. Okay, so if y is equal to c of x times this integral, then y prime will be c prime times e plus c times the derivative of this, and this should be substituted into the original equation, and this constant will be found. The variables will be separated, and we will be able to find the constant. So this is the method number 2. So step number 1, to solve a homogeneous equation. So with a 0 function on the right hand side. And step number 2, to vary a constant, to assume that this is not a constant but a function depending on x, and find c, the function c of x, and the answer will be, so y equals this new function multiplied by this coefficient. This is also a function. Okay, and
the first one is shorter.
maybe so not shorter. So I will show you how to. Maybe we will have a chance to compare two methods. I will not remove this. I will use this space to solve the same task using the second method, right? And we will compare. Maybe the explanation is a little bit too long, but the method is not more complicated. So method number 2. So this was integrating factor. And variation of a constant. So step number 1, we should write, so this is the standard form, and we should write the homogeneous equation y prime minus y equals 0 and solve it. So the variables are separated, and it is dy over dx equals y. So dy over y equals dx, and then integrate, and we have ln absolute value of y equals x plus c, and y equals c times e to x, where c is an arbitrary constant, positive or negative. I think it's clear. It was discussed in the beginning of our lecture, but now, so I think it's clear. Okay, so the first step is completed, but the first step is just one row, and this is the butler. Yeah. Now the second step. We vary the constant. We assume that this is not a constant but a function depending on x. And so y equals c times e to x. We find the derivative. It is c prime e to x plus c times e to x. And substitute this into the original equation. And this will give us c prime e to x plus c e to x minus y minus c e to x equals x e to x. Then we can cancel out similar terms, the same terms. And we have this equation. Next, we can divide by e to x, and we have c prime equals x, from which we obtain that c is equal to the integral of x dx. It is x squared half plus c. So now this is a new constant. This is a constant, right? c1. And after this, so we are done. And now we should substitute the answer into our function. So the answer will be, maybe it's shorter, right? Y equals x squared half plus c 1 maybe times e to x. So the same answer.
Ma'am,
Maybe it's shorter, right?
Papa said he doesn't believe.
Believe what? This is the first method. It's shorter.
No, like this second method we're able to.
Right.
Never mind.
The second, right. I see. So why we can vary the constant,
Yeah.
right? It's yeah, I see. But it works, right? Right. Okay. So it can be proved. It can be proved that so generally, if we represent y as the product, and if we differentiate it, and now if we substitute this into this equation, then this term will be cancelled out. It can be proved. It can be proved, of course, like in method number 1. So I can show you that. So why it works. So if we if we differentiate, right, in details this will be minus the integral of a to x dx plus c times the derivative of this. What is derivative of e? Minus the integral of a to x dx times minus a of x, right? So this is the derivative of y, and if we substitute it now, right, then this term will be eliminated. So this term is always eliminated. So look here. So it should be eliminated. So, and it can be proved general, right, in general situation, for general equation, not only in this particular case. Okay, so it works. There are two methods, but sometimes it is maybe more convenient to use one of them or the other. Maybe, so I have questions, I have tasks, maybe you want to solve them. Okay, so Kathy, welcome. Right. Right. I will give you chalk. So this chalk is not, it's not very good, but I have excellent chalk. Okay. Task number 2. xy prime equals y plus 2x cubed. Welcome. Right. So first to bring this equation to the standard form, right? It's correct. Then find the integrating factor.
Wait, where do we put the constant?
Why the constant? So minus 1 over x. It will be 1 over x, right? And you may skip the constants. So we need only one antiderivative, not all of the antiderivatives. Multiplied by this integrating. Right. No, you may do this.
It's difficult to understand.
Dx. So you have forgotten dx. Right. So x squared, and then divide, so plus c, and you need to add c here, plus c, and then divide by, right, all right, it's correct, thank you. Paul, do you want to try? Chalk. I have chalk. I will use this maybe. Task number 3. Y prime minus 2y equals x. No, it's not so. All right. Yes, well, I have my own chalk. It's better. Okay, correct. Multiply both sides by this integrating factor. And this is the derivative of what? Of y times the integrating factor. And you may check this. Right.
This.
And then integrate. Dx. Do not. Okay, so dx. Dx. Right. Dx. Well, so y times e to minus 2x equals the integral. This integral.
This is x, right?
X. X times, right? It's correct. I have checked. Okay, so you should integrate by parts. So it is not the.
Let me say.
Right. And dv is the other function, right? It's correct. So not one, but dx.
The 1 dx. Yes.
1 dx. Right. Correct.
Sorry, ma'am, I have to remind myself.
uv minus
v
du. Correct. Right.
So
It's excellent.
So uv, that's minus x over 2
minus
integral of v. So let's change
All right.
So x.
Dx and dx. Right. And complete the. So right. So now it's.
Change it back to minus.
Right. And this is the answer, right?
Oh man, I messed it up.
Right. So, or you may write y. So rewrite this part here. Y times e to negative minus 2x equals this. Plus c. You should add the constant, and then multiply both parts by 2x.
by 2x.
Oh, e to 2x.
x.
Right. Multiplied by e to 2x.
So 1. Or just cancel out 10.
Minus, right. Plus c multiplied by e to 2x. You can't leave c, so you must multiply it by e to 2x. They are different functions. So now it's correct. Correct. Thank you. Well, so how? So we must finish in. So we have 20 minutes, right? 20 minutes now. Okay. So let's solve something in just a moment. Okay. Now let's discuss the following. Let it be number 4. First, let's try to solve initial value for problem. Well, let it be y prime minus y times tan x equals sine x, where y of 0 equals 1. Let's solve the initial value problem. Okay, so do you want to solve? Yes. All right, welcome. I will clean this pot. Okay, so let's find the integral and then continue, right? It is more convenient, of course. The integral, tan x, right? Shall I help you?
No.
Do you know how to integrate?
I don't know. I never memorized.
Right. Okay, yes. Where t is cosine, right. It's better to use the absolute value, of course. The absolute value of plus c, right? And then u
is equal to e to the power minus.
Minus t minus, right? Right. It's cos x, right?
Now I need to find out.
Next, multiply both sides by cos x. Both sides of this equation by cos x.
Then
multiply both.
Use the formula. Okay.
You want to use the formula?
Yes. No, I already know that.
Right. You may use it. Right. But if some students want to do it by hand, so maybe it is also possible. So to multiply both parts of the equation by the integrating factor. But you may use the formula if you want.
We multiply by
cos.
Factor, then the result is it's very difficult to write because.
Why difficult? Sine x times cos x, so it's 1/2 of sine 2x, right? Or what's the problem?
Right now we already have functions. If we just use u and y, it is easy. Like
what's the problem?
No problem, nothing.
Right. So u is cos x,
U is cos x and
times sin x, dx.
now we can do it many ways.
Right, right. You may.
Sin x's derivative is cos x.
Right.
So and t is equal to
Right.
y is equal to
Divide by cos.
So I have sin x is tan x.
Tan x times sin x, right? Plus, c. Oh, cos x. And next, so the initial condition y of 0 equals 1. So you may use that part.
Okay.
Right. It's 0.
Y1 is equal to half times 0 plus c divided by 1.
1. Okay.
C is equal to 1. The equation is
right. Yeah, right. In Russia, so students do not like this function, but I know that foreign students use this. Seconds,
favorite.
right. I see. So I have many foreign textbooks, and they use sec x. It is the usual practice to use this function sec x.
Russians always
right?
write
Russian students always 1 over right. Yeah.
I don't know.
Not cos.
COS?
Cos squared x. Right.
No.
and u plus tan squared x equals sec squared. Right? Sec squared x. Right. More compact. Sec x. Right. Thank you. Right. And now, so we will discuss the last problem. I think it is interesting. It would be interesting. Okay. So follow. Now it's your turn, right? So the beginning would be difficult, I think, but now I will help you in the beginning. Okay. So it's number 4, I think, right? Y equals 2y to 4 plus 2x times y prime. So it's x. Okay. So is this equation linear in y? So is it linear?
No.
No, because we have exponent 4. Right. It's not the first power. But the hint is, if we consider this equation not as y depending of x, but if we will try to find the solution in the form x is a function of y, then it will be linear, right? But it is possible to give the answer in the implicit form, right? So using this function, we will give the answer in the implicit form. So we must write the differentials here. So rewrite y prime as the ratio of differentials and move this ratio. So it's not good. Maybe use this chalk, and I will give you better chalk, right? So it's better. I think it's also better. It's my chalk. It's better. So next, move this to the left hand side. So to do this, we should multiply by dx and divide by dy, right? Times y, right?
Okay, now
And now x can be considered as a function of y. It is x prime, right? Okay, so the first step is to rewrite.
Right.
So first, rewrite in the standard form. So you should move 2x to the left and divide by y. Divide by y. Right. Then find the integrating factor. So of y. But you may use no argument
oh,
to avoid confusion, right? U of y next. Do not use the argument, just u equals, right? Is equal to, right, the integral. So first integrate and then, okay, or maybe not here. So and use the integral this way also. So the integral equals, right, so first find this and right. Okay. Next, let's simplify this function. So -2 can be moved to the power of y, right? So not okay. So do not remove, please. Just rewrite.
okay.
Right underneath. E. To the 1, right. And it is equal to, you may continue, equals 1 over y squared.
Oh,
Do not remove.
choose,
It's right. 1 over y squared, and it is equal to 1 over x squared, or y squared, sorry, y squared. Right, it's u. Then multiply.
no, that's not the this one.
1 over y squared, right?
Y. So let's separate them.
Right. And now, so the next step is not to separate. So this is the derivative of which function? Of the function x times 1 over y squared prime equals 2y. Then then integrate both parts, right? Dy, right. Plus c y squared plus c, correct, and then multiply by y squared. Okay, thank you, it's correct. So now the answer is given in as the implicit function. This is implicit function. You need not solve this equation for y in terms of x, right? We are not asked this, so this is an implicit function because it is difficult, of course, This is the fourth order so equation, right? It is difficult.
This is easy to solve. Just assume z is equal to y squared. Then quadratic equation.
Ah, quadratic, right, I see. It is quadratic equation, of course, but maybe the answer will become the sum, I think. It's the big formula, that will be the big formula. So I suggest to leave it in this form. Okay. Now, shall we solve something else, or should we? One task, right? So it's your turn, Kathy. Then it'd be your turn. Okay. It's task number 5. Let it be y prime minus 2xy equals e to the power x squared. And initial value problem.
Okay, everything is given.
Yeah. Right. Now.
Where is u?
U is here.
So.
X plus c, right? The power minus. Right.
Now.
So it's correct, and c. Right. And now the initial value problem. Correct. Let's see. Time e to x squared, right? Very easy. Okay, thank you, Kathy. So I think. Okay. So maybe I think we can stop here, right? So we have 5 minutes, but maybe it's enough. I think we will not study any other method, right? So you should be. Or we may we may try to solve the same problem using using the variation of a constant. Do you want to? No? Do you want to do this? Welcome. So variation of constant, of a constant. Let's exercise this method, the method of variation of a constant. So first we should replace the right hand part by 0, right? We should solve the homogeneous equation first. Equals 0.
What was the next step?
Next, separate variables. Separate variables. I will help you. Right. Okay. Mm-hmm. 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 So no, just we need, not we need, because we will variate it.
Yes, we're gonna variate it. Then substitute. Oh.
Then y, right? So solve for y. C times e to x squared, right? Where c is an arbitrary constant, right? And next we will vary the constant, vary the constant. So we suppose that it depends on x, and we should find y prime. Differentiate this. Right. All right. And times x. To x, right?
Plus
C prime, correct. And then substitute it into the original equation. And two terms must be cancelled out. Substitute into the original equation. Okay, and plus, and where is, so we have forgotten. You missed this. Lost. E to x squared. Then cancel out these factors, and we have c prime equals 1, right?
Okay.
C prime equals 1, and so. And c equals x plus the constant c1. And then this will give us the answer. So y equals, look here, so y equals plus c1 times e to x squared. Okay, and then the initial value problem can be found as before, right? So let's compare the answers. So this is the answer obtained by the first method, and this is the answer obtained using the second method. So they are the same. It can be seen that their answer is the same. It doesn't depend on the method, of course. But you need not to find, so now, so the work is the same. So to find a constant, you should perform in the same way, right? Proceed in the same way. Right. Now we will finish our seminar. Thank you for your attention. See you later, and bye.